This lecture we are going to discuss about the properties of the jet transform, right? So whatever we discuss with the properties of Laplace transform, so we'll get similar properties here also, small variations. Now the first property is always linearity. So what it tells that if two signals are, if we have taken the summation of the two signals with some constant multiplication, so in the z domain also it will be same addition as well as the multiplication with the constant. But what we need to observe is the ROC should be common to this x1 and x2, right? So when we take the summation of two jet transform, so there is a region of convergence where the both the jet transform will converge. So that we need to take the as common ROC, right? The next one is time shifting. So the time shifting means x of n is having a x of z is the jet transform with ROC R. Now when we do the time shifting in the time domain, that is n minus n naught, so in the z domain we need to multiply with z power minus n naught, right? As we have done in the Laplace transform as e power minus s into t naught. So here z is the complex variable power minus n naught. Similarly, if there is some x of n plus n naught, so what can be the z transform? Z power n naught into x of z, right? Now what about the ROC? ROC will be same as R, but the moment when we add z power minus n naught, so there is some possible condition that so it may becomes divergence, right? So we need to eliminate that divergence value. So that's why it is called except for the possible addition or deletion of the origin or infinity. So if we take example, then it will be clear. Suppose what is the jet transform of delta n? It is simple as 1, right? Now if we shift n minus 1, what will get? Z power minus 1. So z power minus 1 means 1 by z. So if I substitute z is equal to 0, it will become divergence or it will be infinity. So ROC is, say for delta n, what is the ROC? Entire z plane, right? But here ROC is entire z plane, same entire z plane, except z is equal to 0. Why? Because when we substitute z is equal to 0, the z transform is diverges. That is the reason we need to accept that z is equal to 0. Similarly, if there is a delta n plus 1, so it will become z. So z means if I substitute z is equal to infinity, it will be diverges. So entire z plane except z is equal to infinity in that case, right? So this is about the time shifting property. So the next property is scaling in the z domain. Now it's looking like x of now e power st into x of n, right? So here x of n is x of z with ROC R. So if we multiply with z power n in the time domain, so in the frequency domain or z domain, so it will be z by z naught. So if it is a power n, so we will get z by a, b power n z by b. And what is ROC? ROC is mod z not into r. So whatever we multiply here, so that will be multiplied in the ROC also. Suppose if I take example like this, u of n, what is the z transform we have seen? 1 by 1 minus z inverse or z by z minus 1. What is ROC? Mod z is greater than 1. Now if I multiply it with a power n into u of n, so a is z naught here, so the constant a power n u of n. So what is the z transform? In place of z, we need to substitute z by a. Yes or no? See here, z by a. So what it will become? 1 minus z by a power inverse. And mod z is greater than, so he said mod z into r. So r is 1 into a. So what it will become? 1 by 1 minus a power 1. So if it is coming to the numerator in the denominator, so a power minus 1. So a power minus 1 into minus 1 means a z inverse. So it is nothing but we have got a power n u of n is nothing but 1 by 1 minus a z inverse, right? So this is the scaling in the z domain. So we need to multiply with some constant power n in the time domain, right? Next one is time reversal. So what is the time reversal? X of n is having x of z with ROC R. Now the reversal in the time domain, what happens in the z domain is it will become 1 by z, right? So r z power minus 1, that is also okay. What about the ROC? ROC will be inverse, that is in place of r we have to substitute 1 by n, something like this. Suppose what is the u of n z transform? 1 by 1 minus z inverse, right? Now what happens when we reverse of this signal u of n? So it will become u of minus n, so it will become z. So what happens to this one? 1 minus, in place of z will get 1 by z power minus 1, and the ROC will become, so z means 1 by z is greater than 1. So what is this? 1 by 1 mod 1 is less than mod z, or we can say mod z is less than 1, right? So what is this? What you call 1 by z inverse means we'll get 1 minus z. This is the z transform of the u of minus n, right? And what is ROC? ROC will get mod z is less than 1. Now we know that whenever there is a u of minus n or minus 1, so the ROC will be always less than 1. And don't confuse with minus of u of minus n minus 1, right? So that is different, this is different, right? So u of minus n minus 1 means what? So we can get 1 by 1 minus z inverse only, and the ROC is mod z is less than 1. Now but see here, u of minus n is different, the z transform is different. Now the next property is the time expansion property. So this property we have discussed in the discrete time Fourier transform, right? So when we do the time expansion, so it should be either xk of n, so this is 2 is the expansion value, so xk of n is equal to, it will become x of n by k if n is a multiple of k, right? Otherwise it will become 0. So what is this meaning is something like this. Suppose if I take x of n, right, there may be 0 at 1, this will get 1, amplitude is the same 2. Now when we want to do the expansion, so what we need to do is we have to do x of n by 2, then it will be expanded, something like this. So n by 2 means each term will be multiplied with 2, so r 0 by 1 by 1 by 2, so it will become 0 into 2, 1 by 1 by 2 into 2 into 2, so it will be expanded like this. So 1 into 2 means it will become 2, and at 2 becomes, it is 4. This is n, this is x of n by 2, which is expanded version of this x of n. So the remaining integer, that is at 1 and 3, the values will be 0. That is meaning of this one, x of n by k. If n is a multiple of k, then only will get the values, sample values. Then otherwise, if it is not a multiple of k, then it will become 0. So something like this. So this is the expansion version of this x of n. Now that is the denotation of this one, xk of n is equal to x of n by k. Now what is the z transform of this type of signal is, x of n is having x of z and ROC is r. Now if we do the expanded, that is xk of n, so in the z domain it will become z power k, right? So z power k means, suppose what is the z transform formula? X of z is equal to sigma n is equal to minus infinity to infinity x of n into z power minus n. Now if I take z power k, so what happens here? N is equal to minus infinity to infinity x of n into z power minus k power n. Yes or no? Now see, now we will get only integer multiple of this one. So when we go for the expanded version of this one, so it will become x of 1 into z power minus k, x of 2 into z power minus k whole square, and so on. Unless until if n is a multiple of k, so we will get the values. If it is not multiple of k, we don't get any value, because this x of n is a expanded version of this k, right? So that is the, we can have the z transform of xk of n, right? So that is some proof for this one. Now what happens to the ROC? ROC will become r power 1 by k. The reason is, so it's very simple. Suppose the example, if I take, suppose mod z is, suppose example is mod z is greater than r, right? Now if I replace z is replaced by z power k, so which is greater than r, so you can take it as it is. Otherwise, if you want to take only mod z, so what we need to do? So we need to take as the root of kth root. So when we take root, any greater than or less than is there, so it will become, so mod z is less than r power 1 by k. Yes or no? So whenever greater than is there or less than is there, if we multiply with minus or if we take square roots or kth roots, so the greater than will become less than, right? So that is the why we got r power 1 by k is nothing but like this, right? See, xk of n means z power k will get, but roc will become r power 1 by k. So that is about this property, right? The next property is the conjugation property. So the simple, x of n is having x of z with roc r. Now when we take the conjugation of the time domain signal, so we have to take the conjugation for the x conjugate of as well as z conjugate, because z is a complex number, so that's why we are getting z conjugate also. And roc, no change in the roc. So if I take some x of n, suppose x of n is a real value, a real signal. So what happens to x conjugate of n is nothing but x of n, right? Then what happens to z transform of this is x conjugate of z conjugate. This will be as it is. That means x of z will become x conjugate of z conjugate, right? So if x of n is real, so what is the meaning of this one is, if x of n is real, so we have got x of z is equal to x conjugate of z conjugate. That means suppose if I take one pole at something like this, so it may be 1 plus j, right? So this is one pole at here. That means the conjugate of this pole will also be in this z plane. So we will get the one more pole will be there, 1 minus z in this z plane. So that is the meaning of this conjugation, right? If x of n is real, so x conjugate of z conjugate is also equal to x of z, right? That is the meaning is, so it will have complex conjugate poles. That is 1 plus j is there, that means 1 minus j will also be there in the z plane. Right? This is real part. This is right. Next property is the convolution property, very important property. That is when we analyze the systems, LTI systems, so we have to do the convol. So when we want to find the output response, so we can take the z transform, then multiplication, then we can get easily the output response. So what the convolution property tells that in time domain, if we take the convolution in z domain or frequency domain, always it will be multiplication, that is x1 of z into x of z. But whatever we have taken in the Laplace transform, always we need to take the common ROC between these two. So R1, R2 respective the ROCs of x1 and x2 of n. Then we have to take the common ROC of this multiplication, that is x1 of z into x2 of z, right? The next property is the differentiation in the z domain property. That is, if in time domain, if we multiply with n into x of n, in the z domain it will become minus z into d by dz of x of z with ROC r. ROC doesn't change when we do the differentiation in the z domain or when we multiply the some n in the time domain. So differentiation in the z domain means we have to multiply with n. So as we have done for the Laplace transform, that is some t into x of t is there, then it will become minus d by ds of x of s, right? So this can be proved from the two equations, that is x of z or x of n value. How to find the inverse z transform or how to find the z transform, right? That you can do on your own, the proof of this one, right? And so these two are not necessary, but you can discuss the first difference. That is, whenever we take the some difference, that is x of n minus x of n minus 1 difference equation, so we can directly take the z transform. So x of n means x of z. Whenever there is a time shifting, we will get z power minus 1 into x of z. So what is the z transform? 1 minus z inverse into x of z. So when we take the summation or difference, always we need to take the common ROC. That anyway with next the accumulation property. So it is opposite of this difference property. That is, if x of n is there, x of z, and the ROC is the r. Now what happens when we take the summation of this x of n, that is k is equal to minus infinity to n x of k, then it will be only x of z by 1 minus z inverse will become. So we have to multiply 1 minus z inverse here, and we have to take the in the denominator as 1 minus z inverse, right? It is looking like convolution between x of n and u of n. Yes or no? That we anyway we know from the Laplace transform property. So something like this. See, some y of n is there, and we are doing the convolution between x of u of n and all with x of n. Yes or no? So what is z transform? So y of z is equal to u of z, right? So what is the u of z? 1 by 1 minus z inverse into x of z. Yes or no? Same as we got. Right? Now, what is ROC of this one? Mod z is greater than 1. What is ROC? So it will be, suppose if I take R, so we need to take the intersection between this and this. Right? Same as this. Right? Then the last property, or generally we can say initial value theorem. If x of n is equal to 0 for n less than 0, that means the initial value theorem is applicable to only causal systems. Right? So x of n is equal to 0 for n less than 0, then x of 0 is nothing but limit z tends to infinity x of z. Remember, we should not multiply with z or s, because in the Laplace transform we have multiplied with s, right? So here in z transform, no need to put z here. So x of 0 if we want to find, so limit z tends to infinity x of z. So in x of z, if I substitute z is equal to infinity, we will get the initial value, right? That is about this. Now we will solve some problems on the z transform using the properties. Just now we have seen the all properties. Using those properties, we will try to solve some problems. Now to solve this one, so first we need to using Euler's relation, expand this one. So this will become e power j omega naught n plus e power minus j omega naught n by 2 into u of n. This is x of n. Again, if I take split, it will become 1 by 2 e power j omega naught n u of n plus 1 by 2 e power minus j omega naught n u of n. This is x of n, right? Now, what is the property we need to use? So the property here is the scaling in z domain property. That is, if there is a z naught power n, some constant power n into x of n. So what is the z transform? Z transform is nothing but x of z by z naught. And what is the ROC? We will get ROC mod z naught into r. Right? That property we need to use. Now, first take u of n. What is the z transform of u of n? We know that 1 by 1 minus z inverse. And what is ROC? Mod z is greater than 1. Now, if I multiply it with 1 by 2 e power j omega naught. So, if I am multiplying 1 by 2 e power j omega naught power n, I am taking like, so I am making z naught power n. So, z naught is nothing but e power j omega naught into u of n. So, the constant will come as it is, that is 1 by 2 into 1 by 1 minus z inverse. Z means, what is the z naught here? So, z by z naught is e power j omega naught. So e power j omega naught power minus 1. And if I write, please simplify this one, this will become 1 by 2 into 1 minus e power minus j omega naught into z inverse. Yes or no? See, e power j omega naught is coming out the numerator, so minus minus, I think it will be plus. So e power j omega naught into z inverse. This is the first part. Now what is the ROC of this one? See, ROC for u of n is mod z is greater than 1. Now what is the z naught here? So z naught is a real or complex number. So e power j omega naught means, if I take mod, so the mod of e power j omega naught is 1 only. So the ROC doesn't change, that is will become mod z is greater than 1 only. So this is about the first part. Now, what is the second part? So this is the second part. So we need to find the z transform, that one also. By looking this expression, we can directly find, that is 1 by 2 e power, in place of j omega naught, we will get e power minus j omega naught power n u of n And this will become 1 by 2 into 1 minus, whenever e power plus j omega is there, now we will get e power minus j omega naught into z inverse. And what can be the ROC? ROC can be same, that is mod z is greater than 1, because it's a complex number. So mod of complex number is nothing but 1 only, right? So that's why the ROC doesn't change for this one. So now the whole term x of n, what is the Z transform? We have to add these two. That is, so see, 1 by 2 is common. So I'm taking 1 by 2 common. And if I take LCM of these two, so 1 minus e power j omega naught z inverse one term, and 1 minus e power minus j omega naught z inverse another. Now the cross multiplication will become 1 minus e power minus j omega naught z inverse plus 1 minus e power plus j omega naught z inverse. And what is the ROC? Common ROC? Mod z is greater than 1. Now to simplify this one, see here, this is 1 plus 1, so it will become 2. Now if I take common, minus z inverse, so what is this one? E power j omega naught plus e power minus j omega naught. That is about the numerator. In the denominator, if you multiply, so 1 into 1, 1 minus e power minus j omega naught z inverse, so minus e power j omega naught z inverse, minus into minus plus e power j omega naught into e power j omega minus j e power j omega, it will be cancelled, it will become e power 0 1, so we'll get z inverse 2, and ROC as it is, mod z is greater than 1. Now see here, see if this 2 is going to the numerator, so 2 by 2 1 minus, this will become z inverse, see it is e power j theta plus e power minus j theta by 2, so what is that? Cos omega naught by 1 minus, if you see, observe z inverse, if I take common minus z inverse, again it will become e power j theta plus e power minus j theta. There is no 2, so it will become 2 times of cos omega naught into z inverse plus z inverse 2, and ROC is mod z is greater than 1. So this is the x of z, right? So remember, whenever there is a cos omega naught n u of n, so directly we can remember as, what is the z transform? 1 minus cos omega naught n z inverse omega naught not n, 1 minus cos omega naught z inverse by 1 minus 2 cos omega naught z inverse plus z inverse 2, and ROC is mod z is greater than 1, right? So this is about the cos omega naught n into u. This problem, that is, in place of cos omega naught n, now it is sin omega naught n. Now the same procedure we need to follow, right? The answer will be somewhat different. So what you need to do is just pause the video, you do on your own, right? Then compare the result with me, right? Now what is the procedure? So just take the Euler's relation, that is e power j omega naught n minus e power minus j omega naught n by 2j. Extra will get 2j here into u of n. This is x of n. Now again split, so 1 by 2j e power j omega naught n u of n minus 1 by 2j e power minus j omega naught n u of n. Now I will go with the direct, this is x of n. So if I take the z transform, it will become x of z. So this is also 1 by 2j means 1 by 2j only, and u of n means 1 by 1 minus z inverse. But there is a e power j omega naught z power n, z naught power n is there. So z by z naught, that is e power j omega naught power inverse, right? This is the first part. Second part is 1 by 2j, same we will get 1 by 1 minus z by e power minus j omega naught power inverse. And what is the ROC? ROC is same, mod z is greater than 1, right? Now we need to only the simplification, so this will become 1 by 2j, 1 by 1 minus, see e power j omega naught is going up, so e power minus j omega, minus will be positive, so e power j omega naught into z inverse minus 1 by 2j, so this will become 1 minus minus, so it will become plus, so plus into minus, again it will become minus, so e power minus j omega naught into Z inverse. So ROC will be same, that we will see in the last. Now what we need to do, just if I take 1 by 2j common and take LCM of these two, so it will become 1 minus e power j omega naught Z inverse into 1 minus e power minus j omega naught Z inverse. No? Cross multiply. So 1 minus e power minus j omega naught Z inverse. So see here, so here minus is the minus of 1 minus e power j omega naught Z inverse. Right? Now to simplify further, see here, this 1 minus 1 will be cancelled. So e power j omega naught minus of minus will be plus. So here the equation will become like 1 by 2j. So it will become, if I take Z inverse common, it will become e power j omega naught minus e power minus j omega naught. See here, minus minus plus Z inverse. So Z inverse is taken common, e power j omega naught. Here minus e power minus j omega Z inverse. Z inverse is out, so minus by, then again same multiplication will get 1 minus Z inverse. If I take common, it will become e power j omega naught plus e power minus j omega naught. Minus into minus plus, so plus Z inverse 2. So denominator as it is, no change as the previous case. Now see, 1 by 2j is, if it is going inside of this one, so 1 by 2j into e power j theta minus e power minus j theta is nothing but sine omega naught into Z inverse by 1 minus, see here, e power j theta plus e power minus j theta. There is no 2, so it will become 2 cos omega naught Z inverse plus Z inverse 2. This is the example of sine omega naught n into u. And ROC is same, mod Z is greater than 1. Right? So this is about sine omega naught into Z inverse by 1 minus 2 cos omega naught Z inverse plus Z inverse 2 for sine omega naught n into u. See, we cannot directly find the using the formula, that is x of z is equal to sigma n is equal to minus infinity to infinity z power minus n. If we follow this procedure, so it is very complex, you will get. So x of n in place, we will get sine e power j omega naught etc. Then we have to use the formula of the summations 0 to infinity a power n, that is 1 by 1 minus a etc. So complex will get, but using these properties will get very quick, right? So that is about this problem. Now there is one more, two problems using this. So a power n cos omega naught n into u of n, a power n into sine omega naught n into u of n. Here we need one more extra what you call it, the scaling property, that is a power n, right? Again you will get z by z. So I'll give for you the assignment something like this. Now it will become x of n, that is a power n x of n. So what is z transform x of z by a, and ROC will become, what is this, a into r. So I will do one, you do the next one. Now something like this. So x of n, what is x of z? So I will take the first one. So what is that? 1 minus cos omega naught z inverse by 1 minus 2 cos omega naught z inverse plus z inverse 2, and the ROC is mod z is greater than 1. Now what we need to do, we need to multiply with a power n, right? So a power n x of n. Now what is the z transform this one? In place of z we will get z by a. So 1 minus cos omega naught into z by a power inverse by 1 minus 2 cos omega naught z by a inverse plus z by a inverse 2. And here mod z is greater than 1 into a. So mod z is greater than a. Now if I simplify this one, so what will get? 1 minus cos omega naught. See here a. A means if it is coming in numerator, a inverse. Inverse and inverse you will get a cos omega naught z inverse. Now see, just a will be multiplied by 1 minus, again 1 by a power inverse. It will become again 1 minus 2a cos omega naught z inverse plus, if a is coming the numerator here, it will become a inverse 2. So inverse cancel, it will become a square z power minus 2, and ROC is mod z is greater than a. This is the a power n cos omega naught n into u of n, right? So this is about this a power n. Now I'll write the directly for this one. See here. So sine omega naught into z inverse. So we'll get a sine omega naught z inverse. The denominator as it is we have to write like this. So 1 minus 2a cos omega naught z inverse plus a square z inverse 2, and mod z is greater than. So this is about these two problems, right? We'll solve this problem. So we need to find the Z transform of this one. Now see, x of n is having, what is the property we need to use? The shifting property, that is x of z. Now x of n minus n naught. So what is the property? Z for minus n naught into x of z. Now u of n minus 3 is there. So to make the total x of n minus 3, so we have to manipulate. This is x power n minus n power. So n minus 3. So what we need to do? 1 by power cube we need to multiply extra to make cancelable this one into u of n minus 3. Now see, this will become 1 by 125 into 1 by power n minus 3 into u of n minus 3. Now we'll proceed further. So 1 by power n u of n. What is the Z transform? We know that 1 by 1 minus a, that is 1 by 5 z inverse, and mod z is greater than 1 by 5. Right? Now when we shift this one, that is 1 by power n minus 3 into u of n minus 3, and we need to multiply 1 by 125. So that multiplication factor will come as it is into, in place of, so whatever we what you call it, shifted, so that will become z power minus, see, 3. So this is n minus n naught, so z power minus n naught by 1 minus 1 by 5 z inverse, right? And what is the ROC? Mod z is greater than 1 by 5, right? Now so this will become 1 by z cube anyway. So z cube means z is equal to 0 anyway, it's not there. So ROC is mod z is greater than 1 by 5 for this one, right? So next we will solve this question. So in this question we need to apply what you call shifting as well as the reversal property. Next we will solve this question. So in this question we need to apply two properties. One is shifting and one is reversal property. So we'll go like this. So it should be n minus 1. So I'm making 1 by 4 n minus 1 into 1 by 4 into u of n minus 1. Now this is some x1 of n. Now what is the Z transform? So we'll go 1 by 4 power n u of n. So what is the Z transform? 1 by 1 minus 1 by 4 Z inverse, and the ROC is mod Z is greater than 1 by 4. Now when we shift, so it will become 1 by 4 n minus 1 u of n minus 1. What is the Z transform? Z inverse, right? Z inverse by 1 minus 1 by 4 Z inverse, and ROC doesn't change, same, mod Z is greater than 1 by 4. And see here multiplication factor is there, so it will become 1 by 4, right? Extra 1 by 4 will come. Now we'll do the first part, that is 2 power n u of minus n. So to do this one, so I'll take 2 power n u of minus n. Now to solve this one, see, the reversal property means, suppose if it is x2 of n is equal to 2 power n u of minus n, right? Now if we take 2 power n into u of n first, then if we reversal, so we should get 2 power minus n. So to solve this one, first we will take u of n. So what is the Z transform? 1 by 1 minus Z inverse, and it is mod Z is greater than 1. Now when we do the reversal directly, u of minus n first, so what it will become? 1 by 1 minus, in place of Z we'll get 1 by Z power inverse, so 1 by mod Z greater than 1. So what is this? So it is Z by 1 minus 1 by Z means we'll get Z, and here mod Z is less than 1. So this is the u of minus n. So reversal is over. Now we will do the scaling in the Z term, that is 2 power n into u of minus n. So what is this? We'll get 1 by 1 minus Z by 2. So Z by a, right? Z by Z naught. So here also Z by Z naught, Z by 2, so less than 1. So what is this? We'll get 1 by 1 minus 1 by 2 into z, and mod z is less than 2. Now if we add these two, that is 2 power n u of minus n plus 1 by 4 n u of n minus 1. So what is the z transform of these signals? Or one is 1 by 1 minus 1 by 2 z inverse no, z is z only, plus 1 by 4 into 1 minus 1 by 4 z inverse into z inverse. And what is the ROCs? So for this one it is less than 2, and for this one it is greater than 1 by 4. Now what is the common ROC? So 1 by 4 less than mod z less than. So this is the common ROC, and this is the z transform. See here, not z inverse, it is z only. See here, right? So this is how to do this. Solve this question. So these type of problems are very important. So we may get questions in the GATE exam like this. So whenever there is a shifting as well as a reversal, so follow the standard procedure. So I will do in a two ways this one. So what we do is, so first make like this: 1 by power 4 u of minus n plus 3. Then take 1 by 4 as it is, u of, take minus common, then it will become n minus 3. Now to do this one, so we'll go first, we'll do the reversal, then shifting, then scaling in the z domain. So three properties we can apply here. The first one is, we will take it as u of n, which is z transform is 1 by 1 minus z inverse, and mod z is greater than 1. This is the first step. Then do the reversal, u of minus n. So once we do the reversal, u of minus 1 means 1 by 1 minus, in place of z we will get 1 by z. So 1 by z power inverse means 1 minus z. Here also 1 by z greater than 1. So what is this? It will become z 1 minus z, and it will become mod z is less than 1. This is u of minus n. Then do the shifting, that is u of minus of n minus 3. So what is this? Z power minus 3 by 1 minus z, and here mod z is less than 1. When we do the shifting, no change in the ROC, unless until there is some exceptional case. So when z is equal to 1, so when it is becoming what you call infinity, so that's why it is not z is equal to 1. So z less than 1, right? So when z is equal to infinity, so 1 by infinity it becomes 0. So it is converges. The moment when it is diverges, then only that exceptional case comes. Next. So up to here is over. Now just a scaling. So 1 by power 4 n u of minus n plus 3. The final step. Z naught power n. So z by z naught. So z by z naught means z by 1 by 4 power minus 3 by 1 minus z by 1 by 4, and in place of z here also z by 1 by 4 less than 1. So what is the final answer? See, 1 by 4 means 4 power minus 3. See, 1 by 4 means 4. 4 minus 3 will be outside, into z power minus 3 by 1 minus 1 by 1 by 4. It will become 4z. Now what is this? Mod z is less than 1 by 4. Right? This is the first procedure. We can do this like this also. Now one more procedure we can follow the, say, so take as it is 1 by 4 power n u of 3 minus n. Now make this one as same the reversal process, that is take this 1 by 4 into numerator, so it will become 4 power minus n u of minus n minus 3, plus 3. Then 4 power minus n, take u of minus common, then it will become n minus 3. Now this n minus 3, make it here also 4 power minus of n minus 3. That means we added 4 cube. That means we need to subtract 4 minus 3 into u of minus of n minus 3. Now go with the standard procedure. So first take 4 power n u of n. Right? Then what is the z transform? 1 by 1 minus 4 z inverse. So a power n u of n means 1 by 1 minus a into z inverse, and it is mod z is greater than 4. Right? Otherwise start with u of n, then go like this also, no problem. Next, do the reversal. 4 4 1 u of minus n. So reversal means 1 by 4 z. So 1 by z inverse means z. And here 1 by z greater than 4. See 1 by 4 greater than z. See z is coming that side. So what is this meaning? Mod z is less than 1 by 4. Right? So this is about this one. Then what we need to do? Just time shift. So when we do the time shift, we should add 4 power minus 3 into 4 power minus of n minus 3 u of minus of n minus 3. So what is the z transform? See, there is no, we need to multiply with this constant, so it will become here also 4 power minus 3 into shifting means z power minus n naught. So here minus 3 by 1 minus 4 z. Right? So what is the ROC? Mod z is less than 1 by 4. See here, so for the first method or second method, we got the same answer. Right? So that's why it's very important. Now you try this one, the question. So maybe 2 power n u of minus n minus 2. Right? So go with the two procedures, one procedure, second procedure, and see that you are getting same answer or not. Right?